Welcome to this deep dive into one of nature's most captivating phenomena, the rainbow. Before we begin, here's a quick disclaimer. This video is based entirely on factual information sourced from scientific studies, expert analyses, and established principles in physics and meteorology. It is intended solely for educational purposes and not as a platform for personal or speculative opinions. Rainbows are not only visually stunning, but are also fascinating from a scientific perspective, as they involve complex interactions between light, water, and the human eye. So, let's break down what causes a rainbow, its effects, and how it has inspired awe and curiosity for centuries. At its core, a rainbow is the result of light interacting with water droplets in the atmosphere, and understanding it starts with the properties of light itself. Sunlight, often referred to as white light, is a mixture of all visible colors. These colors are part of a spectrum, ranging from red, which has the longest wavelength, to violet, which has the shortest. When sunlight encounters a water droplet, it undergoes three primary processes: refraction, reflection, and dispersion. Refraction occurs when light enters the water droplet. Since water is denser than air, the light slows down and bends as it passes through the droplet. This bending is what allows the light to spread out into its constituent colors, a process known as dispersion. Each color bends at a slightly different angle due to its unique wavelength, with red bending the least and violet bending the most. Once inside the droplet, the light reflects off the back surface of the droplet. Depending on the angle at which the sunlight hits the droplet, this internal reflection directs the light back toward the viewer. As the light exits the droplet, it refracts again, further separating the colors and forming the familiar arc of the rainbow. The angle at which this phenomenon occurs is crucial to the rainbow's appearance. The most intense colors are visible when the angle between the incoming sunlight, the water droplet, and the observer's line of sight is around 42 degrees for the primary rainbow. The result is the iconic spectrum of red, orange, yellow, green, blue, indigo, and violet. Observing a rainbow depends on specific conditions. First, the sun must be low in the sky, typically in the morning or late afternoon. The observer must have their back to the sun, and rain or moisture must be present in the atmosphere ahead of them. The combination of these factors creates the perfect environment for a rainbow to form. But did you know there's more than just the primary rainbow? Sometimes, a secondary rainbow appears outside the primary arc. This secondary rainbow is created by light undergoing two internal reflections within the water droplet before exiting. As a result, the colors in the secondary rainbow are reversed, with red on the inside and violet on the outside. Secondary rainbows are fainter than primary ones because each additional reflection causes some loss of light. In rare cases, tertiary and quaternary rainbows can form, but these are usually too faint to be seen by the naked eye. Apart from the physics, rainbows have sparked wonder and inspiration in cultures worldwide. Many myths and legends surround them, often portraying them as bridges to other worlds or symbols of hope and promise. For example, in Norse mythology, the Rainbow Bridge Bifrost connects Earth to the realm of the gods. In Judeo-Christian tradition, the rainbow is seen as a sign of peace and a covenant between God and humanity. Beyond cultural significance, rainbows also have practical and psychological effects. Scientifically, they provide insight into the behavior of light and the properties of water droplets, aiding advancements in meteorology and optical science. Psychologically, rainbows have a profound effect on human emotions. Their vibrant colors and fleeting nature often evoke feelings of joy, wonder, and hope. Studies have shown that exposure to natural beauty, like rainbows, can improve mood and reduce stress, offering a small but meaningful benefit to mental health. Reactions to rainbows have always been overwhelmingly positive, as they remind people of the beauty and intricacy of the natural world. Social media platforms are flooded with pictures and videos of rainbows, often accompanied by captions expressing awe and admiration. Viral videos of rare phenomena like double rainbows or full circle rainbows have captivated millions, showing how this natural occurrence continues to resonate with people globally. However, some reactions delve into the scientific, with photographers and enthusiasts meticulously capturing the physics behind these arcs. Modern technology, such as high-speed cameras and weather monitoring equipment, allows us to study rainbows in incredible detail. Researchers have even recreated rainbows in laboratory settings to analyze their properties further. One of the most exciting effects of understanding rainbows is their application in optical and atmospheric sciences. For instance, studying light dispersion in rainbows has influenced the development of devices like prisms and spectrometers, which are used in fields ranging from astronomy to medical imaging. Moreover, rainbows have been linked to climate studies, as the appearance of rainbows can provide clues about atmospheric conditions and the size of raindrops. While the benefits of rainbows are largely symbolic and scientific, their cultural and emotional impact is undeniable. They remind us of the intricate interplay between natural elements and how science can explain even the most magical-seeming phenomena. Reactions to rainbows, whether rooted in awe or scientific curiosity, underscore the universal appeal of these colorful arcs. In conclusion, a rainbow is far more than just a pretty sight in the sky. It is a testament to the complexity and beauty of nature, a phenomenon that seamlessly blends physics, meteorology, and human emotion. From its formation through refraction, reflection, and dispersion to its effects on culture and science, the rainbow is a source of endless fascination. It connects us to the natural world, inspires creativity and wonder, and reminds us that even fleeting moments of beauty can leave a lasting impression. So, the next time you see a rainbow, take a moment to appreciate not just its beauty, but the intricate science and cultural significance behind it. Thank you for joining me on this journey into the science and wonder of rainbows.